There are three types of questions in a Lewis structure assignment. Question type 1 is going to give you a formula and ask you to draw a Lewis structure and then answer some questions from that. There's a lot of these. Alright, so here's one of the examples. Draw the Lewis structure of PO2 minus. Well, we need to get the number of valence electrons to figure that out. So phosphorus has 5 valence electrons. Each oxygen has 6 valence electrons, and there's 2 of them. That means there's 12 valence electrons, and the 1 electron gives us 1 valence electron. So when we add this up, there should be 18 valence electrons in our structure. So we'll take the phosphorus and add 2 oxygens with single bonds around it. What we will then do is take and satisfy the octets on the oxygens by adding in extra valence electrons. 2, 4, 6, 8, 2, 4, 6, 8. Now there's a total of 8 electrons around each oxygen, and if we count this, it's 2, 4, 6, 8, 10, 12, 14, 16 valence electrons already used. Since we can't put any more electrons on the oxygens, we have to put them on the phosphorus. Now, before I go any further with this, I want to figure out formal charge. But, notice something. This phosphorus here does not have a satisfied octet. It only has 2, 4, 6 electrons. So we need to share some electrons between one of the oxygens and the phosphorus. Okay, so now if we do formal charges, phosphorus has 5 valence electrons, it has 1, 2, 3 bonds, and 2 lone pair electrons, so that's 0. This oxygen is going to be 0. This oxygen over here on the left will have a -1 charge. So, what is the total number of electron pairs in this Lewis structure? If we count that, it's 2, 4, 6, 8. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 electron pairs. Remember, each bond is 1 pair of electron. What is the number of non-bonding electron pairs on the central atom? There's 1 non-bonding electron pair. What is the geometry of the electron pairs around the central atom? Alright, on this question, we need to figure out what type of structure we have here. What is our AX protocol? Well, here, the central atom has 2 additional atoms, so it's an AX2 and 1 lone pair, AX2E. Okay, that means that for electron pair geometry, with everything being the same, it would be a trigonal planar geometry. Now, for molecular shape, because it's AX2E, you recall from our shape diagrams, AX2E looks like this, and it's bent for geometry. So molecular shape, molecular geometry, is going to be bent. And that's how you have to answer this. Please make sure that you use trigonal, planar, and bent exactly how they are spelled in the key at the top of this assignment. All right. Question type 2. Use Lewis theory to determine the chemical formula for the compound formed between Rb and S. So rubidium and strontium. Okay, so if we think about this, rubidium has 1 valence electron. Sulfur has 1, 2, 3, 4, 5, 6 valence electrons. In order to have a complete octet, we need to have something else bonded to the sulfur. So that means we're going to have 2 rubidiums in order to have a complete octet on the sulfur. Okay, so that means we should be Rb2s. Now, please make sure you double check this by using your knowledge of charge. Rubidium has a 1+ charge. Sulfide has a 2- charge. Therefore, you should be Rb2s, which is exactly what you got before. Type 3 questions is going to give you a formula and ask you to tell how many sigma and pi bonds it contains. Now, you don't have to draw these formulas the best, but you need to get an idea in your mind of how many single, double, and triple bonds are present in your molecule. So, for the formula C3H4, all the carbons are going to be connected together. And then we can just fill in with hydrogens. So I'll take one carbon and I'll fill it completely with hydrogens, and I'll take another carbon here on the end and fill that with a hydrogen. Doing that uses all 4 of my hydrogens. But I still have some extra bonds I can use. I'm going to put 2 extra bonds here, because if I count this up, I should have 12 plus 4, 16 valence electrons. I have 2, 4, 6, 8, 10, 12, 14, 16 valence electrons. Okay. So this is propyne. We can also draw a formula where we have 2 double bonds connecting the 2 carbons to the central carbon, and each terminal carbon has 2 hydrogens. This is referred to as an alene, and you'll see this in organic chemistry. Either one of these is an acceptable Lewis structure for the molecule C3H4. Now we just need to count the number of sigma bonds and pi bonds. If we look at the propyne, we get 1, 2, 3, 4, 5, 6 sigma bonds and 2 pi bonds. If we look at the alene, we get 1, 2, 3, 4, 5, 6 sigma bonds and 1, 2 pi bonds. Okay? It doesn't matter which way I drew these, they come out to be the same.